everyone. In this video, we're gonna computer skill lecture. We're gonna look at how can we use Excel to help us to calculate the confidence level of the proportion. And in the lecture video, I already emphasized so the formula for the confidence level for the proportion is will be different from what we learn for the confidence level for mu when we know or unknown sigma, right? So therefore, in this exercise, we will learn how to calculate it. A poll showed that 20 out of 100 randomly chosen graduates of California medical schools last year intend to specialize in family practice. And so as you're reading this case, you should start to documenting the number you read, right? So a poll showed that 20 out of 100 random chosen graduates of the California medical school last year intend to specialize in family practice. Okay, so in this question, so we saw two numbers, 20 and 100. So what is 20 and what is 100, right? So before the first question, number one, is asked for the standard error for the sample proportion. So basically, we're going to figure out what is this proportion about. So this proportion is about the percentage of the graduate will choose California medical school, right? So that is the proportion we have. So as we know that the 20 going to be the number of success, which is X, and the 100 is number of the failure, the number of the sample size. So therefore the N equal to 100. So as you identify those number, and it will be a good idea to go into your Excel, start documenting. So the number of success is 20, and the number of the number of sample size is 100. Okay, based on these two, we are able to estimate value for the P, so which is the probability of success, right? So based on our PowerPoint, let me go back to our PowerPoint quickly. Okay, let's see. So the P is equal to N, X divided by N. So that is the probability of success based on my sample data. So therefore, I'm able to calculating the probability of success equal to 20 divided by 100. Okay, so that gives us 0.2. Okay, so before I want to do any calculation using the formula we already seen from our formula, the standard error equal to sigma p, and the probability of success times 1 minus pi divided by n, right? So people use this formula. So remember the p, the mean of the p is representing our population mean, proportion mean, pi. Okay, so before we're using this formula, we need to double check one more thing is, can we approximating our p to follow this normal distribution? In order to do that, we need to check if the number of success and the number of failure are larger than 10. Okay, all larger than equal to 10. So as we know, the number of the success equal to 20, so that is larger than 10. And the number of the failure, basically the student who did not choose medical school, is equal to 100 minus 20. That gives us 80. So both the number of success and the number of failure are larger and equal to 10. So therefore, we are able to assume my P is following normal distribution with the mean equal to mu, and the standard deviation, the standard error, that is the one we were asked in the first question, right? We want to calculate the standard error of the sample proportion. So therefore, based on the formula, let me just copy that formula. So this is my standard error. Okay, so this is the standard error we're going to use. So therefore, follow the this formula. We just need to type equal. As we already know what's the square root, spell it SQRT, parentheses. And so when you use Excel, the order of the calculation is important. So the first is pi. Like I said, pi is the population proportion. So the expected value of the P is equal to the pi. So therefore, you are using the P value, the P 0.2 times parentheses 1 minus P. Close the parentheses and then divided by the sample size 100, and then now you can close parentheses for your square root, and then you are able to receive the standard error equal to 0.04. Okay, 0.04. It's literally just follow the formula. Okay. Now let's look at the question number 2. B. What is the width of a 90% confidence interval for the population that plan to specialize in family practice, right? So this is the specializing family practice is the proportion we calculated. And after that, we calculate what is 95% confidence interval for the proportion that plan to specialize family practice. So add these 2 sub-questions because in your homework, and so it looked a little bit confusing. So they look very similar, but they are asking a little bit different things. So the first is asked about the width. So how wide my confidence interval will look like. So the other one actually is asking, hey, what exactly that lower and upper bound should look like. So therefore, the formula we're going to use are the same. However, the way we supply or offer our answer will be slightly different. Okay, so B is about the width. So what do we mean by width? Okay, let me look at our formula one more time. When we think about width, so the width is about how wide my distribution, this interval going to look like. So instead of the interval itself, so the width are determined by this section, so the marginal of error. So when we ask for the width, it's actually just asking for the marginal of error. So therefore, the answer is only related to the parts of the plus minus after plus minus this section. So this section tells us how wide that interval going to be. So it does not involve the P yet. So that's the difference. So question number B, when they ask for the width, we focus on the right-hand side, right after plus minus sign this section. And when we are thinking about our width, the interval, then we need to consider, hey, how can we calculate lower and upper boundary? Okay, so if that's the case, I will copy the formula we needed for question number B to address this question. Okay. Oops. Okay, so this is the section we are focusing on, the width, plus minus z statistic, and then times square root of the p times 1 minus p divided by n. Okay, so first of all, let's figure out our z statistic. So based on the part 1's learning, we already learned how to get the z statistic. So for the z statistic, we need to figure out that probability. In order to figure out the probability, we need to know what is our confidence level and confidence coefficient. Okay, so we need both. So confidence coefficient is what we call alpha, right? Okay, we need to know this too. Okay, so first, for my confidence level, let me go back to my question one more time. The question is asked, what is the width of the 90% confidence interval? So therefore, this 90%, that give me the value for the confidence level. So confidence level is 0.9. And the coefficient is 1 minus my confidence level. That means give me 0.1. Okay, so now the probability we are using in the formula calculating the z statistic, remember, is equal to the confidence level plus alpha divided by 2. Okay, so that is the probability we use. So we learned that from the part 1. When we look at the confidence level for mu, given sigma is known, right? Given sigma is known. So norm dot s dot inv parentheses, and then our confidence level plus the confidence coefficient divided by 2. So that's going to be the probability we are using inside this Excel formula. So that gives us 1.64. Okay, 1.64 is the z statistic we're using. Now we have z statistic value, and then we also have the p value, p's value, and we also have n. So now we can start using this formula. So equal to our z statistics, okay, times sqrt parentheses, and then our p times parentheses 1 minus p, close the parentheses, divided by sample size n, close parentheses. I will stay here a little bit. Like I said, as you're watching the lecture video, you can pause this video as you try to double check, make sure you select the right number, and before you look at the answer to make sure you got exactly the same answer as I got. Okay, now I can put enter. Okay, so now this is not width. So the width is plus minus 0.07. So that give me the width. Or the other way you can do, since it's width, so that will be, the width will be from, because it's minus 0.07 to 0.07. So it will be, you also can say it's equal to 0.07 times 2, because on one, on the right hand side is 0.07, on the left hand side also equal to 0.07. So the width for this interval together is 0.14, right? 0.14. But it really depends on the homework assignment question, right? So they give you options. So maybe they give you plus minus sign already. So then you just type in 0.07. But if the question does not have plus minus sign, then you're gonna times 2. That will give you 0.14, right? 0.14. So this is the width. So the answer will be plus minus 0.07. Oops. So if you type on the Excel, will be plus minus 0.07. So that will be the answer for the question, the width. Okay, so now that is the width. The question number B, number C, is literally asking for the confidence interval. If that's the case, we just need this formula. Okay, for the confidence interval, okay, so for 90% confidence interval, and we are able to directly using the formula on the right hand side. So for my lower bound and then upper bound. Okay, so for the lower bound, we are picking minus sign. For the upper bound, we'll pick plus sign. So that will equal to the P we already estimated, okay, minus Z statistic, since it's still 90% confidence, so therefore I can use the Z already calculated. And then times, oh, actually you don't even need to go that far because we already calculated my width, right? So the width here, this number we have here is literally the right hand, the number right behind plus minus sign. So I can minus the width already calculated. So that give me the lower bound. Okay. And then my upper bound, that is equal to P plus my width here. Okay. So in that situation, the 90% confidence interval for the proportion student gonna, medical student choose the family care will be between 13.42% to 26.58%. Okay, so that is the lower and upper bound. How to calculate confidence level for the proportion. And hopefully this exercise help you understand, hey, what do I mean by width? And what do we mean by confidence interval? And how to figure out the standard error for the sample proportion. And in our next computer skill lecture, we're going to focus on our finite population correction factor calculation, how that help us determine if we need to add in that to our confidence interval calculation.